Solving a 3 by 3 system of linear equations. We're going to extend the idea of solving system of equations to 3 dimensions. So you may have done this in the past with 2 equations and 2 unknowns. Well, now we have 3 equations and 3 unknowns. And so you might be wondering, geometrically, what do these look like? Instead of graphing straight lines, these turns out to look like sheets of paper. Or you could think of it as, in geometry, we call this a plane. Okay, spelled P-L-A-N-E, but not your airplane, but more like a plane, like sort of like a plank of wood, that kind of plane. Anyways, the key to these problems is to try to stay organized. So here is a system of 3 equations. I went ahead and labeled the first equations 1, 2, and 3. Now what I'm going to do is I'm going to start organizing some of these equations through a series of procedures. The first way I organize these equations is by multiplying -1 to equation 2. And what does that mean? I'm going to go ahead and write this on here. What does it mean to have -1 times equation 2? Take that equation 2, which is what? -x plus y minus z, and I'm going to multiply the entire sides of that equation by -1. And if you do that, you're simply balancing the equation, and you're going to get a new equation. And that new equation, where did I put it? I put it right here. It's going to be x minus y plus z is now equal to -2. And so every time I reorganize the 3 equations, I'm going to reorganize them again. Notice I actually took this equation because I really like the coefficient of 1, and now I reorganize it by calling this equation the first equation. So that's why there is a renumbering here, 1, 2, and 3 again. So I'm just reorganizing the equations. X minus y plus z is equal to -2. And then I put equation 2 as -3x minus y plus 2z is equal to 1. So all I did was I swapped these 2 equations and renumbered them. Why do I like this equation on top? Because I like the coefficient of 1 in front of that x. From here, I went down here and I reorganized the equations one more time. Now I did 3 times equation 1, which will get you 3x minus 3y plus 3z is equal to 6. And then I purposely wrote equation 2 right underneath that. Why did I do that? So I could temporarily eliminate the x variable. So adding these vertically, I get a new equation, which I called equation 4. You get -4y plus 5z is equal to -5. Now I take equation 1 back from here. I rewrote equation 1 right here, x minus y plus z is equal to -2, and then I use the remaining piece of information to work with equation 1. I can't use information from equation 2 anymore because I did that over here already. So notice this procedure here is now different from this procedure with new information from equation 3. I take equation 1 and I put equation 3 right below it, and once again we're going to add vertically to see what new equation I get. Believe it or not, this is equation 5. This is actually a new equation. You get -4y plus 5z is equal to -5. But notice equations 4 and 5 match. So I got these 2 equations from new information, so I could work with equations 4 and 5 now. I'm going to do -1 times equation 4, and then put equation 5 right below it, and simply add those equations together. We get a very trivial equation. We get 0 is now equal to 0. Well, we already knew that. So that tells us that there's going to be an infinite number of solutions. In fact, the system is consisting an infinite number of solutions, and it's going to be dependent on some variable. So let's look for that dependent variable. one way to find that dependent variable is simply solve for y. So what I'm doing here is I'm going to claim that z is our dependent variable. So if you solve for y, you end up getting that. Y is equal to 5/4 times the quantity z plus 1. You could write out the details yourself. Notice y is dependent of z. Same thing for x. We can go back and solve for x. Where did I get this x variable? I went back all the way over here and I solved for x. So right here, I labeled this equation triple star. Let me put a label down here for it. So triple star. So I'm referencing an earlier point there. And we're solving for x. So if you solve for x, you end up getting y minus z minus 2. And of course, you just substitute. Whenever you see a y, you're going to put 5/4 z plus 5/4, which is right there, and then minus the z, and then minus the 2. And of course, you collect all the like terms, and you get x. Notice x is dependent of z. So in this process, I'm claiming z as a dependent variable. Depending on how you see this problem, some of you will claim x as a dependent variable, some of you will claim y as a dependent variable, but in the end you will actually have equivalent answers. And this is a set of infinitely many solutions. In fact, it's a set of ordered triples. It's right there. So if you pick z to be 0, you're going to find one ordered triple. If you pick z to be 1.2, you'll find another ordered triple that will satisfy this original system. There are actually infinitely many solutions. Pretty mind-blowing.